All right, so yesterday we learned about arithmetic sequences. So the follow-up to that is 12.1.3 geometric sequences. So we're going to be looking at another type of sequence today that we can learn formulas for writing the rule for any term in the sequence or for finding the sum of the sequence. So arithmetic, we learned associate with linear functions. It's something that is adding or subtracting by a constant ratio, common difference, where we thought of that as like the slope. It's just a linear function. And everything you did with the arithmetic sequences is easier if you can remember that it's just linear. So with the geometric sequence, it's a sequence that is a multiplying pattern. So we have a common ratio rather than a common difference, and common ratio being like a common multiplier. So for example, we have a geometric sequence right here. We can see that we have a pattern of times 2, right? So 3 times 2 is 6, times 2 is 12, etc. So that's what makes something geometric. And so on this sequence, we would say that the R value is 2, and R stands for common ratio. D, common difference in an arithmetic, R, common ratio in a geometric. So I didn't fill in the explicit rule for you so that we could just kind of derive it here. So I want to take, first off, arithmetic we think of as linear. Geometric is like an exponential function. So if you have, say, 1, 3 is our first point, and then we've got 1, 2, 6. If we were to graph these points, right, then we've got our third term is way up here at 12, so we have a doubling pattern, and so what we're going to see is just an exponential function, and so you should expect exponents in your sequence rule for the nth term. But where does it come from is, let's just pick out one of these terms and think about where it came from, right? So this is A4, we could call it. It's the fourth term in our sequence, and how it came about was we started with a 3, right, A1, and we've multiplied by 2 once, twice, 3 times. So if we are multiplying by 2 over and over again, then what's happening is we have a exponent of 2's, right? So it's 2 to the something power. In this case, it's 2 to the third. So our A4 is 3, which we can associate with our A1, right? So our first term, times 2, because that's the common ratio. And for A4, it's raised to the third power. If we were to back up to A3, then that would only be 2 2's, it'd be raised to the second power. So we can translate that into a rule for our nth term. What we know that we're going to have here is whatever our first term is, we're just multiplying that by our common ratio. And what we can see if we look at A4 is that the number of times we've multiplied by that R is 1 less than the number term that we're on. So our formula is going to have n minus 1 as our exponent. So much simpler rule for nth term of a geometric sequence. And that's it. A1 times R to the n minus 1. Oh, and I just realized that I did not give you a sequence here when I printed your notes. So in example 1, we'll write a rule for the nth term, and we'll find A8, and the sequence that I'll give you is 5, negative 15, 45, negative 135, etc. So here's our sequence. So I should probably stop saying like this is geometric. You should know, like, I'm not always going to tell you what type of sequence it is. So we'll just make sure that we double check that we see a pattern. So I can see here that 5 times negative 3 is negative 15. I can see that pattern continues here, and I can check that it continues here. So I can see that it is in fact geometric because I have that common ratio. I've got an R value of negative 3. And so, to write a rule for the nth term, that again is just us writing our formula for any value in our sequence, writing the function essentially. And that's A1 times R to the n minus 1. And in this case, my A1 is 5, first term. My R is negative 3, my common ratio, we call that. And that's it. And there's no solving to do because the geometric sequence is kind of already simplified as much as it can be. Do not multiply 5 times -3 because that would go against order of operations. So that's my nth term, and now I can find any term that I want. So I'll find A8 by plugging in 8. And because these are exponential functions, you should expect numbers to get big very, very fast. So you'll get some large numbers. You'll use a calculator for that. And we should get negative 10,935 for our 8th term. And the 8th term is not very far from the 4th term that was the last one I gave you. I mean, the other way we could get that is just by multiplying by 3 a few more times. So obviously we could do that, but we also have this formula to find it. So we're skipping a couple of multiplying steps, but it's essentially the same thing. Okay, so there's us finding the nth rule. Let's step up the difficulty a little bit for this example. Okay, so in example 2, we know that the third term of a geometric sequence is 75/16, and the 6th term is 93/75/1024. And of course, oh my gosh, I didn't write out anything that I wanted you guys to do. So on this question, I should have double checked this before I printed. I want you to find A5. So I really hope you're watching this video so that you can fill in these notes with what should be there. So we're going to find A5. So a little different information here. I have the third term and I have the 6th term. I like to write this stuff out. So I know A3 is 75/16. I know A6 is 93/75/1024. Okay, lots of different ways you could figure this out. I mean, we could be very algebraic about it, or we could kind of be a little bit more thinking about what gaps we have in our sequence. So there's no one right way to go about this, but I know that if I want to find A5, I want a formula. So I want to go back to my explicit rule. That is one way that I could find A5, is to use my formula, go to my explicit rule. Another way I could find A5 is if I knew what R was, then I could backtrack from A6, or I could fast forward from A3. But either way, even if I use my formula, the things I'm going to need are, I'm going to need A1, I'm going to need R. So R is kind of the first thing. So we're going to have to find R. And we had a problem like this with arithmetic sequences. Here are 2 points essentially on your function. Find the formula. And for linear functions, it worked a little differently because I know that it's a common ratio. It's a slope. So I was able to essentially just use slope formula. In fact, I can kind of go back to that for a second. So we did that here. So we had an example in our arithmetic sequences where we found the slope essentially, just difference between the y's, different between the x's. But because that was arithmetic, we were able to do that. Here it's different. So in order to find R, I want to think about what's happening between these terms and what I have. So I do not know the first term. I do not know the second term. I do know the third term is 75/16. I don't know the fourth term. I don't know the fifth term, but I want to find it. And I do know the sixth term, 93/75/1024. Right, so I have A3 and A6. I want A5. And I don't know A1, and that's also something I would want to know for my formula. Now, let's think about how we can find R. So, again, different ways you can do this. But what I know is that A6 is 3 terms away from A3. And then I know that the way that I get to A6 is by multiplying by this unknown common ratio. And so I want to think about how many times. Well, if I write out everything that I've written out, I can physically count how many times. But also I know that there are 3 terms between the third term and the sixth term. So that's 3 multiplying of the common ratio, right? So I know that 75 over 16 times 3 r's, r 3 times, or r to the third, is equal to 9375 over 1024. And now I have an equation that I could solve for r. So I will multiply by the reciprocal here. Cancel out that fraction in front of my r cubed. And there's some simplifying that we can do here. Feel free to use a calculator. This will simplify to 125 over 64 on the right side there. And then I can take my cubed root to solve for r. So I get that r is 5 over 4. Okay, so I have my r, and then again, different ways you could go about this. So what you could do is now just multiply 75 over 16 by r once, again. Another way you could do it is you could backtrack. So now that I know that I'm multiplying by 5 over 4, I could just divide this by 5 over 4. To me, that's inelegant because in this case, I happen to ask you about something that is very close to the values that we already know. So it's very easy to just do that. I'm going to make it a little bit more general, though. I mean, if we wanted to find any term in our sequence, it's good to just write your formula, right? So write the nth term. That's what I'm going to do. So I would write out, okay, my formula is a1 times r to the n minus 1. I now know r, but I don't know a1. So I could use one of my terms to find a1. So that's what I'm going to do. So I'm going to plug in 75 over 16. An just means a term value. So I know a term value. One of my terms is 75 over 16. It's the term that is the third term. I can plug in r now because I know it. So if I want to plug that in, I can plug in 3 at the same time because that's the third term. And then I can solve for my a1. And then I'll multiply by the reciprocal here. And here, I don't know if you see this, but my 16s are going to cancel, and my 25 and my 75 will divide to leave 3. So I've got my a1 now. Now, again, this is maybe unnecessary work. Could I have gotten this faster by just dividing by 5 over 4, dividing by 5 over 4 again? Yes. I'm just trying to give it a algebraic process. And so now I have my a1. And so for my third step, I can use my complete rule or my nth term formula. To find what I want to find, which again I forgot to write, but we're going to find a5 now. So now I can plug in to find a5. So I know my a1 now is 3, my r is 5 over 4, and since I'm finding a5, my n is a 5. Three times 5 over 4 to the 4th. 3 times 625 over 256, which is 3125 over 256. Okay, but again, lots of ways we could do that. I could have just, again, it is, yes, easier on this problem to have just divided by 5 over 4 once I had my r value. But I would say this step is probably some form of this everybody needs to be doing. this is just a process that could work from in step 2 and step 3 for any term that we wanted to find, right? If I wanted you to find a 50, then we wouldn't just be able to backtrack or go through our sequence. We would want to have a process. And so that's what we did here. Okay, that's it. Today we're just going to be we've just talked about the sequences themselves. We're going to have another day on finding the sum of these sequences. So that's it for today.